Last episode, you built something genuinely useful, an assistant that answers from your own notes. And you'll notice it gets some answers wrong. So you do what everyone does. You tweak it. You reword the prompt, you change a setting, you add a line of instruction. You run it once, you look at the answer and you go, yeah, that's better. And you ship it. But stop and ask yourself one brutal question. Did it actually get better? You changed 3 things, you tested exactly one example, and you are trusting a feeling. This is the moment almost every AI project quietly goes wrong, and it is the single skill that separates people who ship impressive demos from people who ship AI you can actually trust. They have one habit the rest skip. They stop guessing, and they measure. So why is looks better such a trap? 2 reasons, and both are brutal. The first, you cannot hold it in your head. Your assistant has to handle dozens of different questions, and the change that fixes this one answer can quietly break 3 others, somewhere you never thought to look. By eye, you will never catch it. The second is worse, and it's about you. You are the single worst possible judge of your own work because you want it to be better so it looks better. That is not measurement. That is hope wearing a lab coat. Vibes do not scale and they are biased. And you cannot improve what you refuse to measure. To actually know, you need one thing you can't argue with and can't fool: a number. So you try to be a little more rigorous. Instead of one example, you run a handful and you read them all by hand. Better. But it falls apart almost immediately for 2 reasons. First, how do you even score an answer? Your assistant says your Netflix renews on the 22nd of November. Your expected answer just said the 22nd. Same meaning, completely different words. A simple exact match check screams wrong, even though it is perfectly right. Remember last episode, meaning and words are not the same thing. And second, reading 10 answers by hand carefully every single time you change one setting is slow and joyless, and you will quietly stop doing it by Thursday. So you need scoring that actually understands meaning and that runs itself automatically every single time. That sounds impossible. It isn't. Here is the first half of the fix, and it is almost embarrassingly simple. Before you touch the code one more time, you write down what good actually looks like. You pick a handful of real questions your assistant has to handle, and for each one the answer you would expect to get. That is it. That little list is your test set, your answer key, and writing it forces you to decide what correct even means before you start tuning. Now watch what happens to the question. Is it better stops being a feeling and becomes something you can literally count? How many did it get right out of how many? Every single change you make, you run the whole test set and out comes a score. You have not improved the AI yet, but for the first time you can see it. But we are still stuck on that scoring problem. The answers are open-ended, meaning matters more than the exact words, and a dumb exact match won't do. So who does the grading? Here is the move that surprises everyone the first time they see it. You use another AI as the grader. You hand a second model 3 things: the question, the expected answer from your key, and what your assistant actually said. And you ask it one job: do these 2 mean the same thing? It reads for meaning, not for matching letters, so the 22nd and renews on the 22nd of November both count as correct. This has a name. It is called using an LLM, a large language model, as a judge. And it changes everything because now you can score 100 open-ended answers automatically, in one pass, the instant you change anything. The feeling is finally gone. You have a real, repeatable number. And for a RAG system, there is an even sharper version of this. Think about why a RAG answer goes wrong. It has 2 completely different causes. Maybe retrieval handed the model the wrong note in the first place, or maybe retrieval was perfect and the model just ignored it and made something up. A single right or wrong score cannot tell those 2 apart, and they need opposite fixes. So instead of 1 gauge, you use 3. 1. Was the note we retrieved actually relevant to the question? That checks retrieval. 2. Is the answer actually grounded in that note, or did the model invent it? That checks honesty. 3. Does the answer actually address what was asked? That checks usefulness. People call this the RAG triad. And now a failing score doesn't just say something is wrong, it points straight at the cause, your retrieval or your generation. You are not just measuring anymore, you are diagnosing. So let's score our Episode 3 assistant for real, free, on your own computer. And this time we don't reuse a question it already got right. We build a fresh, harder test set. 5 new questions about my notes and the answer I expect for each. I run the naive RAG from last time on all 5, and then a second local model, deliberately a different one from the model that wrote the answers, grades each one against my expected answer, just reading for meaning. And here is the result. 3 out of 5. So on 2 of the 5 it was wrong. That is not a vibe, and it is not me being hard on myself. It is a number. And better still, I can see exactly which 2 it failed, and they both failed for the very same reason. The retrieval pulled the wrong note. Look, the music streaming question went and grabbed the gym note, and the video streaming question grabbed the Spotify note. Both are just recurring payments, so retrieval kept confusing one subscription for another. Which is the single most useful thing this whole episode gives you, because now we know precisely what to fix. 2 honest catches before you go, and they both matter a lot. First, your judge is just another model with its own biases. And here is the trap. If you let a model grade its own answers, it flatters itself, it rates its own work higher. That is a real measured effect. So the grader must always be a different model from the one being graded, with a clear rubric telling it what to look for. And there are 2 more biases you will hit right away. Judges tend to reward longer answers, and they can be swayed by the order the options are shown in, which is exactly why you keep a tight rubric. And one more habit that makes all of this pay off. Every time your AI fails in real use in a way you did not predict, you add that case as a new row in your test set, so it grows from real failures and keeps getting harder. Second, and this is the big one. A green grounded score means the answer matches the note you retrieved. It does not mean the note was true. Grounded is not the same as correct. If your note is wrong, your AI will be confidently, groundedly wrong. But look at what you can do now. You have turned "is my AI any good" from a shrug into a number, and right now that number says 3 out of 5. So next episode we go fix the retrieval, we rerun this exact same test, and we watch that number climb. That right there is the difference between hoping and knowing.